This video is about the conjugate addition to carbonyls. We are aware that the average carbonyl has a resonance structure where the carbon has a positive charge on it and the oxygen has a negative charge on it. And this is why the nucleophile always attacks the carbon of the carbonyl, as this is the most electrophilic carbon. Now let's have a look at a conjugated carbonyl. As we can see, it has the same resonance structure as a regular carbonyl, but it also has another resonance structure where the double bond moves. We end up with two electrophilic sites. Let's look at this mechanistically. And just for the jargon, this structure here is an alpha-beta unsaturated ketone. A nucleophile adding on the carbonyl is referred to as a normal addition or a 1,2 addition. Now, a nucleophile can also attack on the beta position to give you conjugate addition. The newly formed anion can now resonate with the carbonyl and then protonate to form an enol intermediate, which then of course tautomerizes back into the carbonyl. This type of addition is often also referred to as a 1,4 addition or a beta addition. Strong nucleophiles such as lithium aluminum hydride and Grignard reagents always do 1,2 addition in high yields. For example, if we take this conjugated aldehyde and react it with lithium aluminum hydride, we will get practically exclusively the terminal alcohol. Whilst if we react the same aldehyde with a Grignard, say benzyl Grignard, we will also see addition the 1,2. What if you want 1,4 addition? Well, you're going to need a weaker nucleophile. For the Grignards, we need a different metal, and the optimal one is copper. We can actually take any organolithium and make it a useful copper organometallic reagent. What do I mean by that? Here's an example. It's important to notice that there are two carbon nucleophiles attached to the copper, but sadly we can only use one of them as a nucleophile. Here we have phenyl cuprate reacting with the same aldehyde as before, and we will notice that it does a 1,4 addition as such. Copper is pretty effective at what it does, so sometimes if you have a copper impurity present whilst you're trying to do a regular Grignard reaction with the magnesium, you will still see 1,4 addition. So let's do a practice problem. We'll react this cyclohexenone with a Grignard and a cuprate reagent and draw the product. Pause the video now. Okay, here are the answers.